Hello everyone and welcome to the e-learning program of HHCP College, Nasik. I am Dr. M.K.Deore from the Department of the Physics, HHCP College, Nasik. Dear students, in last lecture we have seen the crystal structure of two types of the material, sodium chloride and the cesium chloride. Now in this lecture we are going to see again the three types of the material of a crystal structure, such as the diamond, zinc blende and hexagonal close packing type of the structure. The outlines of today's lecture are the type of structure, the types of the voids present in the structure, coordination number, number of the atoms present in the unit cell, and the coordinates of the atoms present in that structure. Now students, now we are going to see the first type of the material is a diamond. We know that diamond is a very popular type of the material because all are using the diamond in the different types of the jewelries. Also, we know that diamond is a very hard type of the material, and due to that it is used as a cutter also. We know the diamond cutters are used for the cutting of the different types of the glasses. Diamond is a very hard material because it is made up of the totally carbon elements, and due to that it is a very hard type of the material. Now basically the diamond having the two type of the structures, one is the cubic and second one is the hexagonal type of the structure. Now but in this lecture we are going to see about only the cubic type of the structure because it is very common type of the structure. Now students, we have already seen about the basic abscissa type of the structure, and in abscissa type of the structure we know that there are the 8 atoms are located at the 8 corners of the unit cell and the 6 atoms are located at the center of the 6 faces of the unit cell. So here we are going to see how there is the formation of a diamond structure. The formation of the diamond structure is simply the interpenetrating of the two types of the unit cell. Now see here, this is the one type of that, the abscissa type of the unit cell, and this is the another type of the unit cell in which the 4 atoms are located at the position on the diagonals of the unit cell at a distance 1/4 of the edge of the unit cell. Now then see here, in this unit cell, if we connect the diagonal of this unit cell, now then see here, from this corner to this corner, now then this is one of that the atom which is at the position 1/4 of the edge of the unit cell. Similarly, if we connect these are two corners from this point to this point, now then we can see here its position is at 1/4 of the edge of the unit cell. Now then, in case of that the third diagonal, if we connect from this corner to this corner, now then its position is towards this corner, and so its distance from this corner, it will be 3/4 of the edge of the unit cell. Similarly, if we connect these two corners from this corner to this corner, now then the atom located on this diagonal, we can see here its distance is at 3/4 of the edge of the unit cell from this point here. So now in this unit cell we can see that these two atoms are at 1/4 distance of the edge of the unit cell from these two corners, and these two atoms are at 3/4 of the distance from these two corners of the unit cell. And if we penetrate this unit cell into this FCC type of the unit cell, along the body diagonal by 1/4 of the edge of this cube or the unit cell, now then the final structure will be look like this. So here these atoms, these dark atoms, that are the carbon atoms occupying the FCC position, and these four atoms will occupy the tetrahedral site. Therefore, in case of that the diamond structure, it forms only the penetration of the two FCC sublattices along the body diagonal by 1/4 of the edge of the unit cell. Now second point, we are going to see about the types of the voids present here. Now we have already discussed about what do you mean by the octahedral site and what do you mean by octahedral ovoids and what do you mean by the tetrahedral ovoids. Now in case of that the octahedral ovoids, now these 6 atoms are get surrounded around the central atoms, and if we connect it, so there is the formation of the octahedron, and if these are the 4 atoms, if we connect it, when they are surrounded around the central atoms, now then there will be the formation of the tetrahedron, and the type of the void is known as the tetrahedron. Similarly, in case of that the diamond type of that the structure, now the 4 atoms which are at the position 1/4 and the 3/4 of the cubic edge in this unit cell, now then if we connect these, now then there will be the formation of the tetrahedral voids. So we can say that now the 8 atoms which are at the corner of this unit cell, it creates the cube. Now then 6 atoms which are at the center of the unit cell, center of the face of the unit cell, then they will create the octahedron. That means here, suppose here if we consider here this is the carbon atoms which is present at the center of this unit cell. Now then if we connect in this way, like this is the upper atoms present at the upper center of the upper face, and this is the lower atoms present at the center of this lower face. So if we connect in this way, now then there will be the formation of the octahedron. Now then, the four internal atoms, those are lying at 1/4 and the 3/4 of the distances along the body diagonal. Now then it forms the tetraorbital type of the structure or the ovoids. So in case of the diamond type of the structure, we can observe that there are the two types of the ovoids. One is the octahedron and second one is the tetrahedron are present in a diamond type of the structure. Now then we are going to see about the total number of the atoms present in the unit cell. Now we know that there are 8 atoms present at the 8 corners of the unit cell, and its contribution is only the 1/8 of that corner atoms, and the 6 atoms are at the center of the 6 faces of the unit cell. We also know that its contribution is 1/2, and there are the 4 atoms which are present internally in that unit cell. Its contribution is full. Therefore, we can say that the total number of the atoms present in this unit cell equal to the 4 plus 4, and that is equal to the 8. So remember that in case of that the carbon type of the unit cell, there are the 8 number of the atoms present in the unit cell. Now then we can see about the coordination number. We have already defined that the coordination number. Now in case of that coordination number, now here that means if these 4 atoms form the tetrahedral ovoids, so the 4 atoms, carbon atoms get surrounded by this single carbon atom. So we can say that the coordination number is 4. So the diamond structure having the coordination number is 4. Now then we are going to see the position of the atoms present in the unit cell, or simply the fractional coordinates of the atoms. Now the coordinates of the carbon atoms. Now here I have given the numbers here. So this is the, if we consider here, this is the origin, this is the x-axis, this is the y-axis, and this is the z-axis. Now then, if we consider the carbon atoms which is at this origin, so its coordinates are the 0, 0. Now second, if we consider this, now then its coordinates which is along the x-axis, so its y and the z coordinates are the 0. Therefore its coordinates becomes the 1, 0, 0. Now then in case of that the third atoms, if we consider here, this is the third atom, so its coordinates are here, this is the 1, 1, 1, because now in this plane here, so if we consider that the age of that the unit cell equal to be the 1 unit, so here its coordinates are the 1, 1, 1. Now then in case of that the fourth, now then here this is the fourth atoms here. Now then in case of this the fourth atom, now it is present at the 1/2 distance of the age of the unit cell on this origin. It is present in the xy plane, so its z coordinate equal to the 0, and here its xyz coordinates becomes 1/2, 1/2 and the 0. Now then in case of that the fifth coordinate, now it is present in the yz plane, so its x coordinate is 0, so here its the xyz coordinates are 0, 1/2, 1/2. Similarly in case of that the sixth coordinate, now it is present in the xz plane. So its y coordinate is 0 and the xyz coordinates becomes 1 half, 0 and 1 half. Now then we are going to see about the coordinates of the atoms which are present in the tetrahedral positions. That means see here, this is the carbon atoms, the first carbon atoms which is present at a distance one fourth of the body diagonal, one fourth of the QH along this body diagonal. So now if it is, now then see here how we can obtain it here. Now then in this case here, now see here in this unit cell. Now see here in this unit cell along this body diagonal. So what will happen here? It is in the xy and the z plane. So its xy and the z coordinates are the 1/4, 1/4 and the 1/4. Now then in case of that the second, now then in this case here that its coordinates are, in case of that the 4 diagonals, if we consider from the front side the atoms near to the corner from the front side, now then its distance is at 1/4. But the atoms which are present on the body diagonals and near to the back side of the corner, now then its distance from the front side will be equal to the 3/4. So now in this way here we can write the coordinates of the first, second, third and the fourth atoms now in this way. Now then see here, now in this unit cell, if we consider here this is the top view. So what will happen here? Now then in this case here these are the body diagonals, now these are the corner atoms and these are the 4 face centered atoms here. So the coordinates of the corner atoms are 0 here like this. Now its distance is 1/2, that means these atoms from the upper face here, it is at the 1/2 distance, it is at the 1/2 distance, it is located at the 1/2, it is located also the 1/2. Okay, now then see here from this point to this point its distance we can see here this is the 1/4, 1/4, 1/4, 1/4. So now we can see here these are the 4 atoms which are at the face centered and which are at the 1/2 distance of the qubits. Now then see here in these 2 atoms they are at the 1/4 distance from this center, 1/4 distance from this center. So here we can write along this body diagonal its coordinates 1/4 and the 1/4. Now then in case of this unit cell, we can see here these are the 2 atoms which are near to these 2 corner atoms and they are at a distance 3/4 from the front, from these 2 carbon atoms. So their coordinates are the 3/4 and the 3/4. So remember, in case of that the carbon structure, how to write the coordinates of the atoms which are present at the 8 corners and the center of the 6 faces of the unit cell, and the 4 corner atoms which are present on the body diagonal of the unit cell. So now in this way, remember about in case of that the carbon type of the structure, the first thing is that how the structure get formed. Second thing is that what are the 2 types of the voids present or available in this type of carbon type of the structure. One is the octahedral and second one is the tetrahedral. The third one is the number of the carbon atoms present in the unit cell. Fourth one is its coordination number, and fifth one is how to write the coordinates of the every carbon atoms present in the unit cell. Now students, we are going to see the next type of the material, and that is the zinc blend, or that is also known as the zinc sulfide also. Now zinc sulfide is the unique compound that form the two type of the crystalline structure. The zinc sulfide is also the inorganic compounds having the two type of the structures. One is woodsite and second one is the zinc blend. Woodsite has a hexagonal structure while the zinc blend is a cubic type of the structure. And here we are going to discuss about only the cubic type of the structure. Now in case of that, the zinc blend, the atomic radius of the zinc atom is 0.075 angstrom unit, and the atomic radius of the sulfur is 1.9 angstrom unit. So we can say that the cations are smaller than the anions. Therefore, we have already discussed about the formation of the crystal structure depends upon the size of the cations and the anions, and also the ratio of the atomic radius of the cation to anion. Now here, the cations are smaller than the anions, therefore the anions form the cubic type of the structure and the cations will be present at the body center. And according to the ratio of the atomic radius, the observation says that if the radius ratio in between 0.225 to the 0.414, then the arrangement of the ions will be able to fit into the tetrahedral ovoids in the crystal structure. So here the radius ratio also shows that which type of the ovoids are present in this unit cell. Now students, we have just discussed about the diamond type of the structure. The ZNS structure is also similar to the diamond type of the cubic structure. Now here, the sulfur atoms having large size, therefore they are present at the corners and the faces of the unit cell. So the sulfur forms the face-centered cubic type of the structure. That is also known as the fully closed packing CCP type of the structure. The zinc having the smaller size as compared to the sulfur atoms, so it is present in alternate tetrahedral ovoid sites produced by the arrangement of the zinc atoms. Now here the zinc ion will have the 4 tetrahedral ovoids in the closely arranged lattice of the sulfur ions. Now here this is the face-centered cubic type of the structure, which is formed by the sulfur type of the atoms. Now then, in case of that this unit cell, now there are the 4 zinc atoms, and these 4 zinc atoms are present along the body diagonal. And these zinc atoms will form the tetrahedral ovoids. Those we have already discussed in the diamond type of the structure. Now then, the same thing is here. The 2 atoms which are at 1/4 distance of the edge of the unit cell along the body diagonal, and the 2 atoms which are at the 3/4 distance of the edge of the unit cell from the body diagonal. Therefore, if these 2 unit cells penetrate, that means we can say that this is the sub-HHCP lattice. So that these 2 sub-HHCP lattice interpenetrating along the body diagonal by 1/4 of the cube edge. Means here, if this is the one unit cell, if the another unit cell is get penetrated along the body diagonal, but it is only at a distance 1/4. So there will be the formation of such a type of the structure, and this structure is known as the zinc blend type of the structure, that is the ZNS type of the structure. So if we connect, that means these 4 atoms form the tetrahedral ovoids. So these zinc atoms, it gets surrounded by these 4 sulfur atoms, and if we connect it, so there is the formation of the tetrahedral ovoids. So remember how the zinc blend structure forms and how there is the formation of the tetrahedral ovoids. Now here we are going to see the total number of the Zn units and the total number of the atoms present in the unit cell. Now here the sulfur atoms which are present at the corners and at the center of each faces of the unit cell. So we know that the contribution of the atoms present at the corner of the unit cell having its 1/8 contribution, and the atoms which are present at the center of the face of the unit cell, its contribution is only the half. So there are the 8 corner atoms, and there are the 6 corners atoms. There are the 6 atoms around the 6 faces. So the sulfur atoms present in the unit cell are the 4. Similarly, in case of that the zinc atoms, now the zinc atoms, there are the 4 zinc atoms which forms the tetrahedral ovoid, so its contribution is full. Therefore, the number of the Zn atoms present in this unit cell are the 4. So we can say that a unit cell has the ZNS has the 4 molecules per unit cell, because the Zn has the 4 atoms and sulfur has the 4 atoms. Therefore, there are the 4 ZNS units present in a single unit cell. Now then we are going to see about the coordination number. Now if we connect the single units in this way, then we observe that now these zinc atoms, it get surrounded by the 4 sulfur atoms. So the coordination number of the Zn atoms with respect to the sulfur is the 4. Similarly, the sulfur atom is also get surrounded by the 4 zinc atom. So the coordination number of the sulfur atoms with respect to the Zn atom is also the 4. So we can say that the structure has the 4:4 coordination. Now then, the coordinates of the sulfur and the zinc atoms. Now those we have seen in case of the diamond type of the structure. Now similarly we can obtain the coordinates, or we can write the coordinates of the Zn and the sulfur atom. So in this unit cell, if we consider here, this is the corner atoms which is at the origin, and if we consider the x-axis, y-axis and the z-axis. So the first atom having the coordinate 0, 0. The second atoms having the coordinate which is at the center of the unit cell, center of the face of the unit cell. So it is present at 1/2 of the distance from the 1/2 of the distance of the edge of the unit cell, and it is in the xy plane. So its z coordinate is 0. Now then, in case of that, the third atoms. Now see here. So it is present in the xz plane. So its y coordinate is the 0. And in case of this fourth, it is present in the z and y plane. So its x coordinate equal to the 0. Now similarly, we can write the coordinate of the z atoms. Now suppose if we consider here, this is the first zinc atom which is along the body diagonal and which is at a distance 1/4 of the unit cell. Now then, its coordinates are 1/4, 1/4 and 1. xy coordinate, xy and the z coordinates are the 1/4, 1/4. Similarly, in case of that, the second, its coordinates are the 3/4, 3/4 and 1/4. Now in case of that, the third coordinate, its coordinates are the 3/4, 3/4 and 3/4. And the fourth coordinate, and the fourth atoms having the xyz coordinates are the 1/4, 3/4 and the 3/4. Similarly, from the top view, we can see here the atoms which are at the corners of this unit cell. Now these are 4 atoms which are at the face center of the unit cell, which is at, they are present at half of the distance of the unit cell, and these 2 atoms which are along this diagonal, and they are present at 1/4 of the distance, and these 2 atoms are present along the another 2 body diagonals, and which are present at the 3/4 and the 3/4 distance from the 2 corners of the unit cell. So now the students, similarly in case of that the zinc plane type of the structure, you have to remember that how the structure get formed. Simply now there is the penetration of the 2 FCCs of lattice. The first one is the FCC type of the lattice, and second sub lattice is in which the 4 atoms are present in the octaorbital site. The second one is that type of the voids present in the unit cell. The third one is that the coordination number. Fourth one is that what is the coordination number of the zinc plane. We have seen that there is the 4:4 coordination is there, and the total number of that the unit cell. So present in total number of the atoms present in the unit cell. So the total number of the atoms present in the unit cell. So there are the 4 zinc atoms and the 4 Zn atoms are present in the unit cell. So it forms the ZNS unit, and so the 4 ZNS units are present in the unit cell. So remember about and how to determine the coordination number of the Zn and S in the structure of the Zn zinc plate. So now students, we are going to see the third type of the structure, that is the hexagonal closed type of the structure. that is also known as the HCP type of the structure. Now here we are going to see how there is the formation of the structure, how many number of the atoms present in the unit cell, and what is the coordination number of the hexagonal closed pack type of the structure. Now initially, instead of the atoms, now we are considering the sphere of the same size. Now if we consider here the 4 spheres, and if we arrange it on the plane surface, so there is the formation of the layer A. Now then, take again the number of the spheres and place a layer B of the spheres over the layer A. The position of the every sphere will be only in the ovoids of the layer A. So it looks like this. Again, take the 4 spheres and place the layer of these 4 spheres over the layer B. Now then the position of all these spheres will be again only in the ovoids. Now then we can see here, if we consider here, this is the first sphere which is in the layer A. Now then we can see here the first sphere of the third layer having the same position. So if we arrange the number of layers of the spheres over the one another, now then there is the formation of the stacking of the layers. So in this way, if we place the number of the layers of the spheres one over the another, now then its density will be also get increases. So here we can see that the sequence of the layers will be the AB, AB, AB like this here. This is only the, we can see here in case of the 2-dimensional arrangement. So, but if we apply the same concept in case of that the atoms in a real structure, so we can observe here in case of the 3-dimensional. Suppose if we, here this is the layer, the atoms which are in the layer A. Now then these dark or black rings which are the atoms in the layer B. So we can see here the position of these atoms of the layer B which are present over the ovoids of the layer A. So we can see in case of the 3-dimensional picture, it looks like this here. This is the A layer, this is the B layer, again the layer A, again the layer B. If we connect the 6 atoms in this way, 1, 2, 3, 4, 5, 6, and if we connect the center of these atoms, now then there is the formation of the hexagon. So such a type of that the structure such as the AB, 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 which forms the hexagonal close packing, and due to that it is known as the hexagonal close type of the packing or the CP type of the packing. Now we are going to see here, if we connect the atoms in this way, in these 3 layers, then we can see there is the formation of the such a type of the unit cell. So here this is the layer A, in which the 6 atoms are at the 6 corner and the 1 atom is at the center. So in a layer B, now there are the 3 atoms inside this unit cell, and again the 6 atoms at the 8 corners of the unit cell of this bottom layer, and the 1 atom which is at the center of the unit cell. Therefore, in case of that, the HCP type of the structure, we can say that the 6 corner atoms in the top layer and the 6 corner atoms in the bottom layer. So there are the total 12 atoms, and the 2 atoms which are at the center of the lower face and the upper face. So these here, and the 3 atoms that are within the volume of this unit cell. Therefore, we can determine the effective number of the atoms present in the unit cell. So the contribution from the corner atoms plus contribution from the basal plane atoms plus the contribution from the atoms inside the body. So we know that the corner atoms, now in this case here, the contribution of the corner atoms in this HCP type of the structure is 1/6 of that atom, and we know that the contribution of the atoms which are present at the face center is 1/2. So we can write here the 12 plus 12 into 1 divided by the 6 plus 2 into 1/2 plus 3, so equal to the 6 here. Therefore, we can say that there are the 6 atoms per unit. 6 atoms are present in a single unit cell. Now then the coordination number. Now see here, if we connect it, so like this here, this is the one of that the atoms. So here this is the one unit cell, and this is the another. Place the another unit cell is placed one over the another. So we can see that the every atom is get surrounded by the 12 atoms. Now see here, this atoms is get surrounded. Now the 12 atoms. Now these are the 3. Now these are the 3, 6, and now these are the 6. So the coordination number of the HCP type of the structure is 12. In case of that, the HCP type of the structure, the density of the atoms is very large, and so its packing fraction is 0.74. So dear students, you have to remember in case of that the HC type of that the structure, how it forms. In case of that the HC type of that the structure, there is only the stacking of the number of the layers. Now there is the stacking of the number of the layers one over the another, and if we connect the atoms present in the every layer, now then there is the formation of the hexagon. So like this hexagonal and this hexagonal, that this it forms the one unit cell, and that is the unit cell of a HC type of the structure. Now there are the 6 atoms present in the unit cell. Its coordination number is 12 and its packing fraction is 72. So please remember all these points related with all these type of the structure, those we have seen for the examination point of the view.